Hello, hello. Wow, got that gain a little bit too high maybe. Hello everyone, welcome to another episode of LeetCode Live, where we do LeetCode questions mainly for fun, try to push the boundaries of what we know, get out of our comfort zone, and really just do some problem solving, because why not, you know? It's a pretty fun thing to do. I just want to do a little bit of housekeeping before I get started. So recently, if you've all been following me on Twitch or YouTube, then you know that I do this every single day. I have most of my content on YouTube, which will remain the same. However, I'm probably going to start focusing more on Twitch for streaming. And then what I'll do is I'll also upload the videos that I stream on Twitch to YouTube. And the reason being is, I'm still sort of like fairly new to the whole streaming thing. And I've tried out several different options. Like I started out with Reddit and their public access network, RPAN, and then OBS, and more recently Streamlabs. And I even used this application called Melon from Streamlabs to do some podcasting. But a lot of these things were costing me money, which I understand. You know, if you want to get into streaming, it's good. You know, sometimes it's good to invest some money because it's better for you in the long term. But after doing a lot of research, I saw there were some very good free options. And of course, you know, a lot of us just want to save money. So I think a lot of these free options only allow for me to stream in one place. And because I typically get more people on Twitch, I think what I'll do is I'll focus more on Twitch in terms of streaming. But everything that I do on Twitch will be available on YouTube. And actually, there's some things that will still only be on YouTube. Like my playlists that I do for the Explore cards will only be on YouTube. Anything that I do regarding front-end projects will also be on YouTube. So definitely follow me on YouTube, subscribe to me on there if that's something that you're interested in looking at and learning more about. So with that being said, you'll see me going a lot back to my stream here on Twitch just to make sure everything's fine. Because now, since I'm, focusing more on Twitch, I want to make sure everything's good there. So if you're coming to me from Twitch or YouTube, drop by, leave a comment, say hi. Always happy to just engage with the community. So with that being said, we're going to go ahead and continue from where we left off yesterday. So we're currently on page 4 of our journey. We're at 271 questions, which again is very, very awesome. And let's just see what we get. So I think the first one, because we left off at same tree yesterday, so let's get to sum of left leaves. All right, so given the root of a binary tree, return the sum of all left leaves. And also let me make sure that this is... Okay, algorithms, easy acceptance. Okay, so everything seems in check, so it's going to be this one right here. Given the root of a binary tree, return the sum of all left leaves. A leaf is a node with no children. A left leaf is a leaf that is the left child of another node. Okay, so the way that I see this is we can iterate through this entire array, and if we ever get to a point where a node's left child is not null, and that left child is also a leaf node, then we can go ahead and return the sum. Else we'll just return 0. So let's see if we can sort of figure that out. That's the way that I would like to go. And let's see. Do I also, I don't even really need to, I guess if we're at a null node or if we're at a leaf node, we can just return 0. At least that's my first to go at this. So if not root or not root dot left. Oh, what happened to my keyboard here? Not root dot left and not root dot right. I want to return 0. Yo, Marvin, what's up? What's good, bro? Yeah, just here. Figured the reason I'm doing a stream a little bit earlier today is because today's my girlfriend's sister's birthday. So I'm very excited to be able to go and visit her family today to celebrate with her sister, because I just enjoy, there's nothing like some good old family time. So I just wanted to do the stream earlier. That way I don't have to be worried about it later. But yeah, I'm doing well. How about yourself, man? Thanks for joining. Always good to see new faces. Or not new faces, sorry. Always good to see returning faces. All right, so if not root or not root dot left and not root dot right, I'm just going to return 0. Now, let's see. For any other one, I can say if... So if not root, what is it that I want to see? I guess if I'm already checking for a null node, rather if I'm already checking for a leaf node, that means anything else will not be a leaf node. So as long as it has a left child, like if root dot left So if root.left, then perhaps we can do return root.left.val and return sum of left leaves root.left plus sum of left leaves root.right. So actually I want to draw this out just to see how it would look. Okay, Scala draw, not X. So let's delete all this stuff here. Let's go to our question. Let's go ahead and draw out our nodes. So we have a 3, we have a 9, we have a 20, a 15, and a 17. Let's draw this whole thing out. Okay, 3, 9, 20, 15, and 7. So let's say that we are just doing the algorithm that we just came up with, right? So over here, we won't do anything like if not root or not root.left, so we don't return anything here. If root.left, return root.value, so we can just immediately return. But why though? Because this would have still returned anyway. So we probably should check to make sure that the left one is also a leaf node. You'll get a six-figure salary job someday. Gambare. I'm not sure what that means, at least that last piece. But at any rate, it's good to see someone new. Always appreciate having new people on the stream. Let us know what your LeetCode progress is looking like. And yeah, we'll go from there. So if root.left and not, whoa, what's happening here? And not root.left.left and not root.right, not left.right. Let's actually do this. And let me put this on a line over here. We have this condition here. Now using this, let me go back to Scala draw. So we start here, we don't do anything. So we go, see here, and this is okay, right? So we do add 3. Now we try to go to the left. Well, this is just immediately going to add. This is only ever going to return root.left.val. So I think what we should do is maybe we need to visit the children first before making that decision. No LeetCode until I need a new job. Same. And the thing is, actually, I'm currently working as a software engineer. I have been working as a software engineer for 5 years. I'm mainly just doing this for fun because it's just a fun exercise to try and do some problem solving. Just doing something different than my normal day-to-day, and yeah, just having fun approaching new questions. But yeah, I'm also not looking for new work, which is why I'm taking a little bit of a slower route. I'm doing all these questions. The stream that you're looking at is not a stream where I really attempt to teach anyone how to LeetCode, or I'm advocating to grind or cram. It's mostly like if you just want to see me struggle and try to come up with an answer, then that's just like, think of it almost like a show that you can watch daily. That is just someone just having fun with LeetCode. But yeah, it is nice to be in the position where you don't have to do LeetCode because it's very stressful, and I've been there before and I totally get it. So maybe what I want to do here, instead of just evaluating it here, should I focus mainly on LeetCode and CS fundamentals or projects for the first job? That's a very good question. I think so. There's like this whole argument of like you should have this stellar portfolio or you need to do some amount of projects. I know that it's getting a lot more competitive now for people getting into the field, but I think, yeah, well, so I think mainly you probably should be doing LeetCode always. As far as the project goes, so yeah, I do agree with what you said. I'll just call you W because I'm not trying to pronounce the next two characters. Yeah, I'll probably agree with what W said. I would only advise for you to do GitHub projects or projects in general if you actually care. Because what happens a lot of times is, people give you advice to do projects and then you just end up doing something because you feel like you have to. Like if that's something you really care about, like if you really care about open source software, then get involved in open source software. If you really like doing side projects, then do side projects. I feel like an employer will be able to call your bluff if you're just doing it to try and impress them versus you did it because you're passionate about it, right? So the only projects I have on my GitHub are ones that I was passionate about. And I hope that for anyone that looks at my GitHub, they can tell that I completed them with some amount of quality that I deem was necessary. Like, there's so many people that do like a to-do list, but a to-do list really won't set you apart from the competition because it doesn't really show that much. Like, everyone's done a to-do list, right? If you have a very novel idea, then by all means go for it. Yeah, I think LeetCode's probably a good thing to spend time on and focus on. So let me get back to this question here, because I think I should do this in like a post order way, where I go down here, this is null, I go here, I don't do anything here, and then I go back up here and I only return. Yeah, I think we can do that. So if I try to do sum of leaves, let's do this and then this. Thank you for the help. I don't have much friends in tech. Yeah, no, that's fine. That's at least something that I hope that I can offer. My own advice. You take that advice however you see fit, of course. But yeah, in my experience, that's it's not too bad. Let's see though, because now I also want to add. If I just return, oh, you know what I can do? I guess what I can do is maybe like return sum of left leaves root.left. Okay, let's do this. Let sum equals 0. I'll come over here. I'll move this if statement up here. Maybe here I can say sum equals root dot, what was it? It was like root dot left dot val. Okay. Sum equals root dot left dot val. And then maybe down here I can return plus this plus sum. Perhaps, maybe not. This might not actually not work, but I feel like this is one of those things with like ordering that sometimes trips me up. Oh, 24 and 24. Okay. I guess that worked, at least for the first one. (24 and 0, 24 and 0). Cool. 8.07. Now is this, okay, this is a binary tree. It's not a binary search tree. So because we can't take advantage of the property of a binary search tree, that all nodes to the left are smaller than its parent and all the nodes to the right are greater than its parent, then I feel like the best conceivable runtime, by the way, that's actually a metric that you can use to try and think about the most optimal solution for an algorithm, the best conceivable runtime, because by it not being a binary search tree, we probably can't get log of n time, but we at least can do O of n, which is what this solution offers, right? We're pretty much going through every single node to try and get the sum of all the left. So because of that, I'll say the time is O of n. And the space complexity, like the internal stack space that this will take, at best, if it's a well-balanced tree, will be O of h, where h is the highest depth at any point. And I say well-balanced because if you think about a tree that only has right children, that's pretty much a linked list, right? A linked list has a single pointer pointing to its next node. A binary tree that only has right children is just a linked list rotated. If you've never thought about that, it's actually kind of interesting. Like you can literally take, right? Like imagine a binary tree. And I've said this before in other streams. I just want to make it known again. Like if you have a binary tree that looks like this, and let's just put other numbers here like 5 and 3, right? The space complexity of this is going to be O of n, because for every single one of these calls, we're adding a new record on our stack, and we're having to build up that stack, and it's essentially the size of the tree. But if you get this whole thing and then rotate it, which I think I could do here we go. If you like rotate this, that's a linked list. Like the only difference between a linked list and really a binary tree with only one child is just the rotation. So something interesting, that's like a cool perspective a friend told me about a long time ago. I thought it was pretty interesting. So Yeah, I'm pretty happy with this question. I thought it was solid. Let's go ahead and run it again. Maybe there's a, okay, 99.55. I was gonna say that maybe there's a better way that we can do it if we try to do it iteratively, but it seems like this one's pretty good. So let me check Twitch again. All right, everything's looking good on Twitch. Cool, let's get to the next one. So that was sum of left leaves. Okay, let's do the next one. So check array formation through concatenation. Okay, you're given an array of distinct integers R and an array of integer arrays pieces where the integers and pieces are distinct. Your goal is to form R by concatenating the arrays and pieces in any order. However, you're not allowed to reorder the integers in each array pieces. Return true if it's possible to form the array R from pieces. Wait, do they just want us to, oh, concatenate 91? And then 4 and 64 and then 78. Oh, I see. So when I look at this question, and if I can't reorder pieces, unless, well, we can't reorder pieces, but we can perhaps, Your goal is to form an array 16, 18, 49. Even though the numbers match, we cannot reorder pieces. We can concat 91, and then we can put 4 and 64 and 78. Here, we can concat 49. Wait, so why can't we do this? Oh, because we have to take this whole thing as 1. I see. Okay, no, yeah, I see. So it's like, okay, I'm looking for 91. Is there a subarray that has 91? Okay, then I look for 4. There is one that has 4 and 64, and then I look for 78. Now, when I look at this question, I guess a brute force way to do it essentially is like for the length, every time, like, okay, 91, I search for a 91. 4, I search for a 4. That's like n, and then also n squared. That's like n plus n squared. That seems to me like an n squared algorithm, because every time I go to n, I have to go through each one of these arrays, and for each of these arrays, I have to go through whatever amount of items they have, which I guess isn't really n by n. It will be n by m. So we can actually say like x plus yz, something like that, let's say, where x is the length of this, y is the length of pieces, and z is the length of each individual array. That's like one way that we can do it. Obviously, it's not the best. Something else I'm thinking about doing it is like, we can't reorder pieces, but I can also store the numbers. I can store the numbers in maybe like another data structure. And what will that tell me? I have a 91. Okay. It's not enough, like, by this example, we know it's not enough to just have all the numbers present. They also need to be like 16, 18, 49 is one unit, and all three of those need to be represented in the same order. Like, it would have to be 49, 18, 16. So let's think about this. Distinct integers array. It's definitely like a key point here. We can it goes to form an array by concatenating the arrays and pieces in any order. Okay. What can we do with this one? Because again, it doesn't matter that all the numbers, it's the ordering that matters, right? Because here, if like 78 was inside of this array, then we'd still have all the numbers, but 4 and 64 next to each other. Is there any way that may be okay? I mean, what we could do is maybe we don't even have to worry about, I guess we can, like, well, this is going to sound kind of maybe obvious or kind of dumb, but like there's either going to be like there's one solution that works. In other words, we can concatenate all different pieces to come up with this, or there's one that doesn't. So maybe we can be greedy in that, okay, when I'm looking for 91, I can just take, let me see. Okay, like this is what I mean. Okay, let's say we have pieces. Okay, now what if I were to go through pieces and I constructed like a hash table that had the position where this was at, like 78 is at 0, 4 is at 1, and 91 is at 2, right? And then I loop through R, and then I say, okay, the first one's 92 or 91. Is there a 91 here? Yeah. And it's a position 2, so just let's start creating a new array with whatever's inside of pieces at index 2, 91. Okay, then we get to 4. Do we have a 4? Yeah, it's at 1. Just concatenate that whole thing. Then we get to 64, and we don't have anything, so that's fine. But presumably, it's okay because it was already covered by a previous one, because we only need to, I think we only need to get the first one. Now, if this was the other way, if this was 64 and 4, that would still be fine. We look for 4, there's nothing, but we get 64, and that would be here. Maybe. No, yeah, okay, that's fine. And then let's say we get to 78, because then I guess what I can do at the end is after doing the concatenation myself, I can just compare the numbers at each index, if that makes any sense. But there might be, like, I can build the array myself and then loop over the input with the thing I just constructed and compare the numbers in both of them. Maybe that's one way of doing it, because I need to know what group they came from. If it was 91, 64, I mean, let me actually see if that even works. So if I did, let's see. Let's say pieces indices. I'm gonna make this an object literal. I'm not in love with this solution yet, but at least we can get something on the screen. So for const piece of pieces, right? I only want the first number. And actually, let me make this for let I equals 0, I less than pieces dot length, I plus plus, const piece equals pieces of I. So pieces indices of piece of 0 is equal to I. Then we can say const formed array, let's say, is equal to this. I can go through, let's see, for const num of R, I want to see where inside pieces this number is. So const index equals pieces indices of num. If index is not equal to undefined, right? Because there's a chance that it might be. If index is not equal to undefined, then we can do formed array, and let's do a let here. Formed array equals formed array, and we can do pieces at index. And then finally, for let I equals 0, I less than formed array dot length, I plus plus. If formed array at I is not equal to R of I, return false or return true. Maybe one thing that could work. Let me see. I feel like I wrote this maybe kind of fast, but that's true and true. Got a lot of different test cases here, which is nice. So we got true, false, true, true, false, true. Wait, let me submit this and see what happens. 1357, 2468, output true, and this is false. Okay, obviously this is something. So what happened here? Because we never found, in this case, we have pieces indices. So we only found 2, which was never found in input. So const index of 1, this is always undefined. Then we get to for let I equals 0, I less than formed array dot length. Oh, and this also returns true. So what? Let's see. I guess we could also say they need to be. I guess here we can have a check that if formed array dot length is not equal to r dot length, we could return false here, since the newly generated array should at least be the length. And I think this is why, because formed array was 0, but array had a length of 4. So then in this, it never came in here and it just returned true. But it should return false if they're not the same length. So what I want to do is I want to copy this. I want to put this here. Let's run this for that test case and see. It's an interesting question. I'm not, like I said, I'm not in love with my answer, but it's something. Let's see if it works now. So 17.65. I mean, I feel like I need to walk through this because I really just don't want it to, I don't want to go too fast and have it go over people's heads just in case. So what I did was, let me clear this. So let's say we have pieces, we have our array here. Let's say we have like this. So I just want to copy this. Let's make this large. Okay. Right, so I created an object literal. And what this object literal does is it goes through pieces, right? So it says that 88, the first thing in pieces 88 is at 0, and then 15 is at 1. Now, like, even if this had more numbers, we only care about the first number because, like, the first number in this array needs to be the next thing that we look for in array. I really hope that makes sense, but like, and maybe it's more evident with the next example. Or like here, like 91, 4, 64, 78. Like we know 91, we say that's an index 2 inside of pieces, and then 4 we know is an index 1. Now, we don't care about the 64 because whenever we look for 4, we know it's in 1, and we can concat both of these into our result. And anything else that's inside of this array is fine. If I don't find it again, there's like, it's a combination of that and also that everything's distinct. If these weren't distinct and there was like another 64 in here, then that wouldn't work because 64 can both be the beginning of one of these subarrays, right? Well, it could be the beginning of a subarray or it can be inside of another one, just not at the beginning. But these are all distinct. So 4, if it's there, it'll be the beginning of one subarray that we can concat. We get to 64, and if we don't find it, that means it's just part of another array, and that's fine. Because at the end, everything will be put in the right order. So once I start creating this array, what I do now is I loop through my original, like, let's say I have my result here, and now I'm looping through R, right? ARR. So I go to 15 first. I say, well, 15 is in position 1. So I want to add everything in the array at position 1 to my current result, which is 15, right? Then I get to my next thing, 88. 88 is at position 0. So the subarray at 0, I want you to get all the elements in there and add them to my current array, 15 and 88. And then at the end, I just compare all the elements in the newly created array with our input array and see if they're the same. We ran into an edge case where we also needed to double check that the length of the new thing is equal to the length of the original thing, else they wouldn't be the same, right? Now it looks like perhaps we could do better. I'm gonna run this again. I'm gonna submit it and see what we get. 29.41. So I'm gonna assume we're gonna trend under 50%. But let's see. Let's do it again. Okay, wow, 50%, right on the money. Give me a second. I'm checking Slack. All right. One more time for good luck. Let's see if we can go past 50. 47.06. Okay. Very curious to see the discussion here. I feel like we can learn something really good. Okay, so, well, I like that they use the map, and if I see x of 0 for x and x pieces, okay, yeah, that's pretty much what we did. Then we do the result. For num in R, res plus or equals np.get num. Okay, they're literally doing the same thing, but Python has nicer ways to compare two arrays. Arrays.equal, yeah, I don't think there's actually, is there anything for that? That'd be very cool. I don't think so. I've never heard of that, but it would be nice if there was a method that allowed for us to compare arrays like that. But okay, so that's awesome because this is literally exactly what we did, except Python just has nicer ways of handling equality. But yeah, they're creating what looks to be like a new dictionary. For every x in pieces, they're just taking the first element and then they're just adding it to that resultant array, just like we are. So that's cool. I'm happy about that. All right. That was, okay, reformat the string. Yeah, I think we're doing pretty good today. You're given an alphanumeric string. Alphanumeric string is a string consisting of lowercase English letters and digits. You have to find a permutation of the string where no letter is followed by another letter and no digit is followed by another digit. Okay. Okay, so we can return any permutation. So input is 0, A, 1. Okay, I see. I think what we can do here is we just try and do it. And what do I mean by that? Like, it'd be nicer if there was a better solution here, but here, like, we can have, let's see, maybe we can have, like, I'm trying to see like the best way of creating this. We can have two arrays that have like alpha characters, like A, B, and C, and numeric characters 0, 1, and 2. And then we just start alternating. Now, well, let's see if that works. Is we can pick an A, we can pick a 0. Okay, that's fine. Let's see if there was only like 2. Like, why would this not work? We pick an A, we pick a 0, we pick a B, we pick a 1, and then we pick a C. Like, that would also work, right? No two adjacent characters have the same type. So that would also work. A0, B1, C. And we've already used everything. LeetCode wouldn't work because we only have alphas. No two adjacent characters have the same type. I'm trying to think if there's like a way that we can build this. I really want to do something like this where I'm like I'm selecting a character, a number, a character, a number, and then just figuring out as I go along. Here again, we only have numbers. So after I pick a number, I would like to pick, oh, you know what we can do? If we only have a 0 and not a 2, anytime I pick a new one, I can go through the length of this. I can pick a letter, I can pick a number, I can pick a letter, I can pick a number, I can pick a letter. Now, if I'm done and there's still, let me see. If I make it to the end and there was always, if I make it to the end of the string and I always had something to pick from, then I'm good, else I return false. So we have these two arrays and I'm like using this to sort of be my guide. So at position 0, I say, okay, let me pull out one alpha I can. So let's say we pick C and we move on. Let's go to 0 and let's say, okay, now a number. Okay, we can. Then I go to B. Let's get B, that's fine. Then I go to 1, let's get 0, that's fine. Then I go to C, let's get A, that's fine. And now I'm done. Every single time throughout the iteration of this string, I had an available character or number to pull from. But now with this, if we start at 1, and you can imagine here we have all these numbers, I say, okay, let me pull number. Now I'm here, I'm not done iterating, and I don't have any alpha characters. So I think this is a way that we can do it. It'd be nice if I didn't have to also create. It'd be nice if I didn't have to create it, but I'm assuming that if we just get the count, then there is a way to have them. Yeah. So when can we not? Like if I have 2 and 2, I can do A1, B2. If I have 2 and 3, what can we do? That would work because I can do 1A, 2B, 3C. Okay, now if I have 4 alphas and 4 alphas and 2 characters, 1A, 2B, 3, I don't have another one. So what if the count has to be the same or maybe only differ by 1? Is that a way that we can do it? That might be the answer. I think we just take the count and then we say, does it differ by, are they the same, or is the difference between them less than or equal to 1? That might be a way of doing it. That might be the way. Let's see. Let alpha count equal 0. Let digit count equal 0. So for const c of s, if, I'm going to use regex here, and this is lowercase, so we're going to do a regex a through z dot test c. So if this is an alpha, we'll do alpha count plus plus, else we'll do digit count plus plus. Now I wonder if we can do return math.abs of alpha count minus digit count is less than or equal to 1. Does that work? What? Oh, wait, what am I doing? They want me to create, they don't want me to say if it's true or not. They want me to actually create. Okay. Well, maybe this is the way to figure it out, but let's go back to our original thing and let's create these arrays. So let's say alphas and digits. If it's an alpha, we'll say alphas.push c, else digits.push c, right? And then we can say I guess we can still do for const c of s. Oh, wait a second though. Does it matter if it's 2 and 4? If I have 2 alphas, I can't do B1, C2. I need to do 2 first. Actually, no, this will fail anyway. If I did 3, if I had 2 alphas, A1, B2, I have no other alphas, I would have to start with, I guess I have to start with the larger one. I think I always have to start with the larger one, else we can pick whichever one. So let's see. For const c of s, we pick alpha first. So we can say, maybe I can say let pick alpha equals alphas.length is greater than digits.length. Okay, here, and then we'll also say, let's do let result equal an empty string. So for const c of s, so we said we're going to go through this and we always need something to pick from. So if pick alpha will do something, else we won't. At the end of each one of these, we should do pick alpha equals not pick alpha. So we do the opposite one. So if we pick alpha, And here we say if alphas.length is equal to 0, we return empty string. Here I can say that if we're picking digits now, if digits.length equals 0, we return empty string. Else to result, we can push alphas.pop. And then here we can say result.push digits.pop. And then I guess we can do return result.join. There's probably like a way nicer way of doing this, by the way, because this is not even, well, let's run it. Okay, so 2C1B0A. No, two adjacent characters have the same type, right? 2C1B0, okay, that's fine. LeetCode should be, let's see, we should get empty strings for the next ones. Empty, empty, okay. So let's see. 65.22. So, see, this is interesting because if pick alpha will pick alphas, so the only thing that's different is this. Well, okay, yeah, these are not the same. I mean, even though they're the same form, it's not always the same result. So probably that should remain the same. And maybe what we can also do is like push an A and then we'll push a 0. Push a B1, C2. No two adjacent characters have the same. A0. Wait, but isn't this already right? Like, this is already good. Yeah, I feel like this is all right, but there's probably a way of doing it without this piece. That's the piece that I would like to try and figure out. Because I just need to know thinking about this. S consists of only lowercase English letters and or digits. What's like the most effective way for me to see if there's something else that I can use? Maybe like L. So now I'm trying to find a digit. So you have A, okay, try and find digit, cool. Now we try to find alpha, okay. Try to find, okay, but what if it was like, if the input is A, B, 1, 2, 3, C, 0, 1, 2, and A, B, C. So how would this work? Like, if I'm at the A, I can pick the A, and then I want to find, you see, but then we also need to pick which one's the longest, which is also a little bit difficult. Let me run this again and see what we get. 23.19. Is there like a better data structure that maybe we can use for this? Because my thing is like, I'm going to store the alphas and the digits, and then based on whichever one of those is larger, that's the one that I'll start picking from first. I'm thinking about this. I keep submitting hoping that like for some reason, yeah, this is gonna stay probably below 50 from what I can see from the amount of times that we've run it. Something that maybe would help. No, actually, no, it wouldn't. I was gonna say we can create like an array of size 26 since it's only lowercase characters, but that doesn't help me easily figure out like the next available thing. Because something else that we can also do is like, I mean, the brute force way is like I iterate over the string and I always try to find like the next alpha or the next, have I considered that? What if I just write down the indices of each one, A, B, C, and then 0, 1, 2? Well, even if I wrote the indices of them, would that let me get to the next one easily? No, I think an array is really good for that. I'm gonna go ahead and read the discussion here to see if we can learn something new from this. Simple, easy with explanation. Okay, this is okay, so they have string A and string D. Okay, they're storing it into 2 just like we are. If the difference is more than 1, return blank since it's not possible to reformat. Well, I guess that's something that we could have thought. So that thing I did earlier of trying to figure out the difference between them was right, and that's perhaps the thing that's preventing us from gaining some optimizability, if that's even a word. So if is out. Wow, this is literally like verbatim. You could dry this out by setting the value of alpha based on A dot size greater than D dot size. That's funny. Yeah, we pretty much did that almost verbatim, like the solution. So that's always nice when what you came up with is like similar to the highest voted answer. Cool. Let's move on to the next one. We're doing very good today. I'm really, really happy about how many we've done. We've done 3, and that's like, by the time we pass 250 questions, like doing 3 or more in an hour, I think is nice. I think the next one is, kth positive missing number. Given an array R of positive integers sorted in strictly increasing order. Okay, when I see strictly increasing order and sorted, I'm thinking about binary search, I think. Because do we really have to worry about, let me say the missing positive integers are 1, 5, or maybe not. Maybe that's not what it is. I mean, the missing positive integers are 1, 5, 6. So k equals 5. And there will always be a missing one in less than O of n complexity. Yeah, because what we can do is we can do like a loop, right? We can do a loop from 1 through some number and then figure that out as we're going along. Binary search to me sounds like probably a way to tackle this. I see sorted arrays, and that's the first searching algorithm that comes to mind. And what we should do is, what's the constraints here? R dot length is less than 1,000, and R of I is less than 1,000. But really, maybe we just need to go between, let's see, k is 2, but then that's 1, 2, okay, that's 6. 1, 2, 3, 4, 5, 6, okay. I'm thinking about binary search, and I'm thinking of what would be our low and what would be our high. 2, 3, 4, 7, 11. And I know that it can only get up to 1,000, right? Like the length is 1,000. The highest number is less than or equal to 1,000. I'm sorry, my dog is scratching his bed because he's scared of a little bit of the thunder. When you start, low and high would be exactly what you think. So you think, so you're saying that low. Oh, by the way, Steve, good to see you again. I know that you were around yesterday, so that's awesome. Thanks for joining. And look at that, I can see you on Twitch now. I'm gonna start paying more attention to Twitch and stuff. So that's very cool. I guess the quality on here isn't as nice as it is on YouTube, unless 1080p source. Is this better? We're going meta here. All right, cool. So 0 or maybe 1 and 1,000, but how does that let's see. If I pick like an arbitrary midpoint, let's say that's like 500. 500's greater than my biggest thing anyway. But then here, how can we solve for that? K equals 2. It wouldn't be 2 and 11 because it's like midpoint of that is what, 6.5? So it will be 6. 6 is not there, but like what position is it in? Your first low should always be 0 and your first high should always be length minus 1. Right, no, I understand that. I understand that piece, but it's more like, is it length minus 1 of the array? Or like, that's, well, I guess, yeah, if I'm searching through this array anyway. So if we pick an arbitrary endpoint, or midpoint, if we pick an arbitrary midpoint here, it's going to be 4, but like, what does that tell me? That it's 4. The kth positive integer that is missing from this array. Yeah, actually, wait. Now I think I understand. I think I get it now. I just thought about something, because if every number here was available, like, okay, we have 1, 2, 3, 4. If I pick 0, right, so if we do 0 and 3, that's divided by 2, that's 1. So if the value at nums or r at I equals I plus 1, then we have everything up to that point. This is like a thought that I'm having. Because like, if I do low plus high, 0, 1, 2, 3, 4, divide by 2, we have 4 here, which means that I'm missing a 1 because 0, 1, 2, no. Well, this should be 2. No, I'm sorry. This would be 3 if we had the 1. This should be 3. Okay. Now, if I picked like 7, we're missing the 1, a 5, and a 6, because this should be 1, 2, 3, 4. So at this position, we're missing 3 elements so far, 1, 4, and 5, right? If I pick 11, then we're missing 1, 2, 3, 4, 5. We're missing 6 numbers up to here. Right, we're missing 1, 2, 3, 4, 5, 6 numbers up until this place. Now, how do we get? I think it's something like that. That's pretty tricky, actually. But I think I'm on the right track here, because if we're missing 6 numbers, I'm looking for the 5th one. So the 6th one we're missing is 10. Now, it doesn't necessarily mean that the 5th one is 9, because like 5 or 9 might be here, but I guess if it was there, I feel like it's something like that. Now, the one that's tricky for me is like here. This is 1, 2, 3, 4. I'm not missing any here. So how do I keep going up from here? I guess if I reach the end, I can just add 2 plus the last one to get that number. If like low and high are equal and I still haven't gotten my answer, maybe I just return this index plus k, and that gives me the value that I'm looking for. The missing positive integers are 1, 5, 6, 8, 9, 10. Because it's sorted, and if all of them were present, then that wouldn't be 11. That would be 1, 2, 3, 4, 5. 5 should be there, but we're at 11. That means we're missing 6 numbers. It's something like that, but I can't quite put it into code right now. Can't put it into code. Let me see something here real quick. Oh yeah, 3 people. Nice. Gotta start growing the Twitch community. Gotta start giving back to Twitch. Let me see. Sorry, I had to check on something. I had a Slack message. Yeah, I think I'm gonna leave this one for a weekly roundup, or maybe like tomorrow, because I do feel like I'm not convinced that like just because I know 1, 2, 3, 4, 5 that this should be a 5, but I'm at 11. It means there's 6 numbers, so like I just need to return like 6 numbers from here. I need the 5th one. So the one prior to this one is the 6th number. And then, like, if there was a 9 here, well, I guess if there was a 9, and I guess this would also, if I land in the 7, 1, 2, 3, 4, this should be a 4, which means there's 3. 3 is lower than the 5th one, so go up. Then I get here, it should be 11, and now the difference is 5. So maybe I need, actually, wait up. Let's actually do that. Let me try with that. So let's say let low equals 0. We'll say let mid equals 0, and then let high equals r dot length minus 1, while low is less, while low is less than or equal to high, sure. Mid equals math.floor of low plus high divided by 2. Now, let's say if we get here. So here we have low and high. So 0, 1, 2, 3, 4. 0 plus 4 divided by 2 is 2, and that gives us here. So I'm looking for, let me see, so what's the difference? I'm at a 2. I'm looking at 2, and this is position 4. This should be 3. So it's like the number that it should be is 3, but I'm at a 4. So there's one missing number. That's what I need to get. So like, let me see. It's like the difference between whatever my midpoint is. Maybe it's just the distance. 1, 2, 0, 1, 2. But that should be a 3. How do we say this? Like, maybe like let correct number equals mid plus 1. I know that's like a terrible, maybe like not the best variable name, but what I'm thinking is like mid is 2. The correct number here should be 3, because I think this is from 1. So then the amount of numbers I'm missing, like if I get to 0, 1, 2, 3, the correct number should be 4, and now the difference, so let's say let missing numbers equals math.abs of r at mid minus mid, or minus correct number. And then here, because r at mid would be 7, but the correct number should be what? 1, 2, 3, 4. So the missing numbers is 3. Now missing numbers, right? If missing numbers is less than k, then we need to go up. Yeah, low equals mid plus 1. That's if it's less than k. And I'm gonna guess that if it's higher than k, else if missing numbers is greater than k, then high equals mid minus 1. Now what happens here? Because this is 1, 2, 3, 4. We have low and high. So 0, 1, 2, 3. 3 divided by 2 is 1. So we get to this midpoint here. So 0, 1. The correct number is 2. So this is fine. 2 is equal to, if missing numbers is less than k. Oh, but the correct number, missing numbers is r of mid, which is 2, minus correct number, which is 1 plus 2. If missing numbers is less than k, then we go low equals mid plus 1. So we do low equals mid plus 1. So then we get here. Now we do again 0, 1, 2 plus 3 is 5 divided by 2 is 2, because we do truncation, which gives us 3. The correct number is 3, and missing numbers again is 0. So now we get low and high are the same. 0, 1, 2, 3 plus 3 is 6 divided by 2. We get here. Again, it's 0. This is 0, so maybe we can just say, and maybe we should make this low is less than, or maybe low is less than high, so we don't even get to this position here. Now at the end, I want one where like this isn't the case, because if low is that, now if I get here, missing positive integers, I should have stayed here, right here. Low and high, 0, 1, 2, 3, 4, mid is 2, correct number is 3, so there's 1 missing, 1 is less than 5, so we'll make low where the 7 is. So now it's 0, 1, 2, 3 plus 4 is 7, divided by 2 is 3, so it's going to be here. This is going to be 4, 4 is less than 5, so low is equal to this one. So I guess maybe it should be this one, or it should be like that, so that way low and high can be the same. Then we get to mid. We'll calculate mid, 1, 2, 3, 4, 5. Correct number is, 0, 1, 2, 3, 4. Correct number is 4 plus 1, 5. If r of mid 6 is greater than, so now 6 is greater than k. I guess if missing numbers is greater than k, do we just return r of mid minus k? Else maybe at the end we would just return r of low plus k. Yeah, this is definitely a very modified binary search question. That's what I'm thinking. That's what I'm thinking. I want to see what this returns just for fun. Okay, so 6 and 9. Output is 6, and we expected 9 here. R of mid minus k. If missing number 6 is greater than 5. Oh, maybe we should do... Well, no, that will still be the same, because mid was the same here, right? Yeah, 6 and 9. Okay, let me revisit this real quick again. Okay, so we have low, and we also have high. Low is less than or equal to high. Mid is low plus high divided by 2. So we have 0, 1, 2, 3, 4 plus 4 is 4 divided by 2. That's going to set our midpoint right here at mid. Can't return just because you found more missing numbers. What you really need is left bisect or lower bound, not a binary search. Let's see, left bisect or lower bound. Slightly confused by that piece when you say left bisect or lower bound, but it's good, something good for me to think about though. They're the same idea, just different exit conditions. Nice. Yeah, and I almost, actually now that you're mentioning that, it almost makes sense because I'm only ever accounting for like my low going upwards, but then here it's kind of saying like at some point I just care about what's on my left. I hope I'm communicating that all right, but I sort of understand what you mean. One second. All right. So like in Python. This method in the standard library is called bisect left, and C++ is called lower bound. Same idea, just different names. Nice. Let correct number equals mid plus 1. So mid here is 2, and there should be a 3. So missing number is less than k. So we want to do low equals mid plus 1. So now let me go up here. Let me go over here. Now we do 3 plus 4 is 7, divided by 2 is 3. So mid becomes this one. Mid is 3. The correct number should be 4. This is 3. That's less than k. So now low is going to be where high is. So let's do low. And then I'll create my mid up here since it's going to be the same. Correct number is, let's see, 0, 1, 2, 3, 4. There should be a 5 here. The difference is 6. 6 is greater than 5. So I want to return array.low. That's the interesting thing. Why am I getting, and where would even that be coming from? Array of low, which should be 11. Oh, wait a second. No, I did. Where did I get 5 from? Oh, okay. Yeah, it's like I need to get, this is, let me see. Missing numbers is 6. And I'm looking for 5. So maybe what I need to do, yeah, okay, I think I know. It's in my head. I'm just trying to think about how to put this in code. So my missing numbers is greater than k. So it's like I need to do array.low. Let's see. I'm gonna do some crazy calculation right now. Like seriously, I apologize for what you're about to see. It's making kind of sense in my head, but just gonna see if that works. And if that does work, I'll explain my thinking, because this should do 11, and then we get the difference between how many we want. So there's 6 missing numbers, we want 5, so that gives us 1, and then we just do another 1 since we don't consider the one that we're currently on. And if that doesn't work, then we'll just wrap it up since we're over the hour. Normally I like to keep these about an hour in length so that people that are watching this later can just focus on watching an hour and they can continue on doing other stuff throughout their day. It's important for me to stay consistent so that others can stay consistent. So here we got not a number, and I'm almost sure that's because, so after this, what happens? Like low is less than or equal to high, right? But then we get to, if I were to remove this condition, let me see, just for fun at this point, 16. So we get the second one right, but now the next one is the wrong one. So this one failed because low probably went out of bounds. However, would my mid be in here? Low is less than or equal to high. The mid will be the same thing. Then I go to low. If I were to do like mid here, okay, this will, let me see what Steve said. I think it's here. You have to continue the search. Okay, we got 9 and 6, 9 and 6, but okay, if this is correct, I think it's me just finagling, whatever that word is, a ton of code to make things work. I'll submit this and let's see if the LeetCode gods are on my side today. Looks like it's gonna be TLE. Time limit exceeded, boys. Classic. Yeah, modified binary search is a very important algorithm to learn here. Okay, cool. So I'm good with this. Like I feel like I still learned a lot. Let me see what Steve says here. So you don't have enough information to return at line 20. All you know is that there's at least k missing numbers at this point, but you likely haven't finished searching yet. Yeah. No, it's like you don't have, yeah, exactly. Like I need to figure out what that condition is. Like how do I mutate the high piece, right? Else I don't even need that variable. Anyway, I think this is good for today. This is a great candidate for like a weekly roundup, a question that we'll inevitably get to at a later point. So I really appreciate everyone watching today. Thanks, Steve, for being very communicative and very active in the chat. I really do appreciate that. I think it helps me grow as a LeetCoder, and hopefully for everyone else that watches, they'll also feel the same. So with that being said, I hope you all enjoy the rest of your Monday. I know it's, Mondays, sometimes they can be hard, sometimes they can not be too bad. Hope you all enjoy the rest of your Monday. Happy coding, and I'll see you all next time.